I wanted to extend the discussion on algorithms from the class today a little bit to give you a couple of different things to think about when you think about algorithms, and also to give you a little bit of justification as to why we're even talking about pseudocode in this class, which is a Java class. Okay, so first, a little bit about algorithms. To remind you of the example that we talked about, this is the example, and if you want to think about it again, or if you weren't in class, I'll give you a second to think about this problem. You can pause the video, think about this problem. Okay, so in class, students realized that the problem with this algorithm was that the steps were in an order that would not work. In other words, the area calculation is done before we know anything about width and length. So as people, you and I maybe look at directions like this, and we might say, well, I know how to do an area calculation, so this is not a problem. It's right at the beginning, it's just telling me how to do the area calculation, and then later we get some input for width and length, and then we just display the area. We do the calculation when we need to, and then we display the area. Well, that may be how you and I think about it as people, but these steps of this algorithm are not listed just to explain how the algorithm works. These steps are in a specific order because they're telling you exactly what to do at every moment of this algorithm, and they're meant to be done in a very specific order. So this is not a description of how this program works. This is the steps that someone or a computer will go through when they do this algorithm. So the first thing it's telling us to do is to calculate area, and we can't do that yet because we don't have the proper information. It's not telling us this is how you calculate area. It's saying calculate area, do it, and we can't. So the students who identified this were absolutely correct. That's the problem with this algorithm. So let's take a look at another algorithm and see if we can identify a different kind of problem. So here's another algorithm, and I'll let you think about this for a second and see what you come up with. Okay. So there is a problem with this algorithm as well, and you may have thought that what the problem is that it's calculating area incorrectly. In this case, the commands are, the steps of this algorithm are in an order that will work. Okay? It's getting the width information, it's getting the length information, and then it does a calculation, and then it outputs the result of that calculation. All that works. That's a proper algorithm, but the calculation is not an area calculation. And if you identified that as being incorrect, then you are right. However, I need to point out that when I showed you this algorithm, well, you may have assumed that the purpose of this algorithm was the same as the purpose of the other algorithm. I actually didn't specify what the purpose was. And that's important because, not because you would look at this algorithm necessarily and say that it was correct, but to know exactly what's wrong with an algorithm, you really need to know what the purpose was. So for instance, if we were using the same, if it was the same purpose as the previous example, then we'd want to fix the calculation so that it was actually an area calculation. However, maybe the purpose of this algorithm is to calculate perimeter, in which case the calculation is correct, but the label that we're using for what we get out of it is wrong. So we would need to edit the word area and replace it with perimeter, and then that would fix the problem. The reason I point this out is that the meaning of an algorithm and whether it's correct or not and how to fix it depends in part on, and in a very large part, on what the purpose of the algorithm was in the requirements that were given. So it's very important to check an algorithm against its requirements and always look back to earlier phases of a programming project and see if you fulfill the previous phase when you are done thinking about the current phase. Okay, so a final thing I want to talk about in this video is I want to talk about why we're even using pseudocode, or why we would write an algorithm like this rather than just go straight to Java code. The reason we're using pseudocode is because part of what you'll do when you are writing a program, when you're solving a problem with code, is you are analyzing the problem. And eventually you then synthesize a solution to that problem. Analyzing means to break down something, to break it down so that you understand it, and then synthesizing means you kind of build up. You build up the solution based on your understanding of the problem. So we can't always synthesize a solution right away based on just reading the requirements of a problem or project. Often we have to go through some steps before we really understand what's going on. Pseudocode can be one of those kinds of steps that you go through to help you understand the problem, to understand your own thinking about the problem, and to understand how you're going to address the solution and build a solution that works. So, a real example of this that may occur in the class is that before you know how to write Java code, you may get an assignment where you have to write Java code, and you may feel like you're spinning your wheels, or you may feel stuck because you can't actually write the code to solve the problem. Well, if that occurs to you in any point, like in a lab or in a homework assignment, I encourage you to use a method like this to write the steps of the problem, or to write the steps of a solution down in pseudocode as best as you can think them, get your ideas down on paper like this, and then look at what you've got, think about it, and refine it before you move on to a step of writing actual code. You could also write it down and bring it to a TA and maybe ask to have your logic checked, or bring it to me during office hours and have me check it for you. The point is that if you don't produce anything, if you're spinning your wheels, it's very difficult to get useful feedback. But if you produce something like this, not only can you see your own thinking and perhaps have a chance to refine it, but you can have a chance to get feedback from a TA or from me, and this may help you get to the next step of the process of synthesizing a solution. An example from real life might be you could come up with a set of directions to get someone to your house. Let's say you've got a long set of directions that you're going through. You're trying to tell them over the phone how to get to your house, and you get like 3/4 of the way into the description, you realize that there's some construction on one of the roads, and the description that you've given them isn't going to work. And so actually you need them to go back in the description in their mind and take a detour way back near the beginning when you were only 1/4 of the way through. If you had written those directions down instead of just telling them over the phone, you probably would have found the error in your directions before you were ever talking to them, and then you would have had a chance to change those directions, and so that by the time that you were reading them the directions over the phone, they wouldn't be confusing. You wouldn't be sending them back. You wouldn't be telling them to, oh, forget what we just talked about for the last couple of minutes. You need to go back to Elm Street, and instead of taking a left, you need to take a right there. Of course, this is really the same sort of thing, but in a different situation. We are writing code, and sometimes we need to see how we're thinking about it before we actually write the code, and this gives us an opportunity to review it, to reconsider parts of it, to refine it, and also just when you're stuck, writing pseudocode is a way of thinking about the problem and make progress on it. It's always better to produce something to make progress than it is to remain stuck. I hope this video is helpful to you.